I'm going to try to do a brain dump on you and try to kind of keep it relevant to things that would be helpful to you. Just at a high level, these carburetors are essentially the same or very similar to what you find on a weed eater or chainsaw. You know, they're designed to run at any angle, and instead of having a bowl on the bottom, they've got a bowl mounted on the side with the diaphragm. So under this little kidney thing here, you've got a low-speed jet and a high-speed jet. The way it works, you probably know this already, but you've got fuel pressure that's pushing underneath this needle. It's a needle and seat, and these are 38 millimeter carburetors, and they actually use a remote fuel pump, so they just have a single pulse line. So fuel's trying to come in, and once fuel is in here, I'll skip how it got in there, I guess. Pushes this diaphragm's nipple away from this lever here, and pushes the diaphragm all the way against this cover. As fuel is being drawn through, past through this hole here, past this anti-siphon valve, which is a little one-way clear check valve. It's feeding in through the jets, and as it's going through, got the Venturi effect, flowing through the throttle. It's creating, suction here essentially. Here's the vent and the cover that allows the diaphragm to be pulled. And after the fuel is nearly out, it starts pulling the diaphragm, which this nipple pushes on this lever, and that pulls the needle away from the seat and allows fuel to flow back in and fills this cavity again. So that's happening just over and over and over again, just filling, emptying, filling, emptying, filling, emptying. And it's important that happens at the right rate. And if you're running, factory airbox, you should be able to use the factory rated spring here. There's 3 or 4 different spring weights, all the way from I think like 68 grams to 98 to I think 110. Whenever you're running the factory airbox, you need a really heavy spring, because your signal is so strong. You're creating so much vacuum because these are restrictive, that you need a heavy spring to fight against that. One of the big issues with running a triple in a jet boat, the 1200s especially, they shake a lot. Their phase balance, being a 3-cylinder 2-stroke, they fire once every 120 degrees, which is balanced, but they're mechanically imbalanced. They have a secondary imbalance, and Yamaha doesn't run a balance shaft like Sea-Doo and Kawasaki do on some of their engines. So the engine sits here and rocks like this, and in a jet ski hole, the hole will actually move a little bit and like dampen the rocking. But in a jet boat where you've got really wide beam, and you've got usually another triple next to it that's also rattling like crazy at idle, a real common problem is that it'll shake so much that it'll actually, this seat will rattle, or the needle will rattle off the seat and allow fuel in when it's not supposed to be coming in here, and that'll cause a dribble. You'll get fuel dribbling into the mouth of the carburetor, which it should be misting in, when you're not supposed to, and it can actually cause the engine to run away. I've had it happen to me on the hose. If you're in the water, you've got a load on it, it won't happen. Way to try to sort of mitigate that risk is to run a larger needle and seat, because then you have more surface area. The common sizes are 1.2, 1.5, and 2.0. The early 1200s had 1.2s. I think they actually went to 1.5s later. The size of your needle and seat also affects your pop-off pressure. There's charts that show you how to calculate that. Again, if you leave everything stock, there's really not a lot of calculations you have to do. So the two main wear components in these carburetors, these are, like I said, Mikuni. You want to only use genuine Mikuni parts. The two main wear components are these diaphragms, and then the check valves, and some of the other diaphragms that are in the pump body. So again, these are 38 millimeter carburetors. These are easy to show you, so I'm showing you those. But they have a remote fuel pump. On the 44 millimeter carburetors, every carburetor has its own dedicated fuel pump. So the 44s are a little harder to deal with because they're mounted sideways. You have to remove the carburetors from the rack in order to rebuild these fuel pumps. What I do, and several other people do, in order to make them more reliable, is there's a restriction inside this pump body that keeps the pressure inside the carburetor. So, pressure is being built. And let me turn these around. So this is the intake side. So this is where the fuel is coming in, and this is where the fuel is going out. And the factory configuration is to restrict the fuel before it comes out, and that helps keep the pressure in the pump body or inside the carb body so that it can shoot into the bowl, under high pressure. The issue with this is that if you're running 3 individual fuel pumps, any one of these can fail at any time, and the rest of the pumps may still be working okay, which will cause you to burn up a cylinder. What I do is I drill out that restriction so that all 3 fuel pumps are working together, and it kind of turns this into a fuel rail. So then, instead of having 3 times the risk that you could burn up the cylinder, you've got redundancy. You've got 3 pumps. You could have this pump fail, not a big deal. You could even have 2 pumps fail. As long as you still have 1 pump working, you're good. These pumps can actually supply enough fuel for I think it's 180 horsepower. You really don't need this many fuel pumps. Let me get my train of thought again. So these are the high-speed jets here, and they're kind of difficult to get to. If you're running the factory 1200 airbox, you have to take the whole airbox off to get to these. I'm running 3D printed knobs on these to make them easier to adjust. I'm not suggesting you get flame arrestors. The 1200 airboxes are actually pretty good. They have a velocity stack inside the airbox, so they actually perform pretty well. One other thing I'll talk about is oil injection. So I really like running oil injection, especially these later pumps that they're better at varying the flow of the oil because they're tied to the throttle. The older style, like on this 1100 here, is like a static flow rate other than the RPM, so they don't vary near as much as this newer design though. So these just barely dribble any oil at all at idle, which helps it not smoke as much. The pumps are super reliable and virtually never fail. And they have check valves in them, which some other manufacturers don't use, which the check valves are real helpful. You just need to make sure you have good oil lines. I run Tygon. It's kind of like some kind of plastic hybrid. I wouldn't recommend using Tygon for your pulse lines. So here's some nipples that go to the pulse lines, and that's where you're getting your vacuum to run your pumps. You definitely want to use this OEM Yamaha rubber on those. A couple other things. This may be just extra information, but these 1100s run parallel timing, so all 3 cylinders run the same timing curve. On the 1200, in order to try to kind of mitigate heat, they run 3 individual timing curves. The middle and the rear cylinders run a little hotter than the front cylinders. I can explain why, maybe another video. So there's a comment there. I want to talk about cranks. One other comment, I guess general comment about jet boats, that era that you have, Yamaha jet boats, or kind of jet boats in general, back then they weren't putting any kind of rudders on them. So, the more freeboard you have, the taller the gunnels, and especially if you have a bimini top on there, you get any kind of breeze and the boat just drifts. So if you're near a dock and the wind's blowing, it'll blow you into the dock or it'll blow you into another boat. So you're constantly having to modulate the throttle. They started adding rudders later to mitigate that. Other issues, they're pulling a skier or wakeboarder, something like that, or kneeboarder, and they go out and cut and they start pulling hard. They actually pull the boat off track. They'll make you start running at an angle. To retrofit your style boat, they make steering nozzles that have rudders on them that help you hold the water a little better. Those may be a little harder to get now. I've seen them for sale used before. So that's a tip there. Other thing is the clean out ports, the big rubber plugs that you remove so you can stick your hand down in the pump to remove any debris. Those are really bad about getting stuck, and I know a lot of owners remove those plugs anytime they're not running the boat in the water, and I think they grease them as well, because it's not uncommon to get something stuck in your pump and you can't get the plug out to get your hand in there. All right, stop this one here unless I'll make another one if I think of something else.